Okay, so I'm gonna talk about some preliminary results on this question. To what extent does backpropagation in a neural net select the most frequent weight space function that agrees with the training set? So what that means is we're going to be interpreting a neural net, this is the neural net right here, as a Boolean function. So we do this by running the neural net on, the vertices of the hypercube, if you will, or not. Yeah. So we run it, and then we compute the sine function of the output, because like the output of the neural net is a floating point. It's not like a plus or minus 1, which I'm using to represent the two outputs. So we use the sine function, and then we convert it into like a string, and so like these are the Boolean functions, and so then we just sample like 2000, and we keep track of the frequencies, and this is what happens. So the constant functions are most frequently represented. Then like I guess functions with like a single accept. And then you also have functions that are like input identity functions. And then like, like single accept functions seem to be popular. Don't really know why. Overall, this distribution looks like this. So this is frequencies of dimension 3 Boolean functions and neural net weight space for this particular neural net, which was just like arbitrarily kind of number of layers and number of units arbitrarily chosen. I don't know, I mean, you could probably say like, oh, what if I make more units? Does that change the distribution? But so yeah, I don't know what kind of like probability distribution this is. Is it a power law? Maybe it's a power law. I don't know. So yeah, like that's weight space for neural nets, and so the whole idea is like, if I have a training set, okay, so like a training set is just like, okay, on these particular inputs, the output has to be, whatever. That's the training set, inputs, outputs. So for all these functions, which by the way, not all functions there's 256 Boolean functions, and so like on dimension 3. So when I sampled 2,000 of them, it didn't discover all of them. Okay, so what was I talking about? Yeah, okay, so like a training set, like a training set is like, so for all of these functions, like there's some subset of them that are compatible with the training set, meaning on the inputs and outputs, they agree with the training set. So you could think of like when you train a neural net to converge on the training set, you could just say like, what it does is it ends up with like the most frequent function that agrees with the training set. So like that's what we were trying to investigate. Probably poorly, but so let's look at the results from that. So like we generated a training set. So we're just saying like, out of the inputs, the 2 power n possible inputs, we select a subset of them. Like in this case we're hard coding it, but it's like arbitrary. And then these are the outputs that it has to map to. So then what we do is we again instantiate the same neural net from before, like the same type, and we train it to converge on the training set. Actually, that's this line. And I just run it for like a fixed number of epochs because, like, I mean, technically I should have trained it until the error on the training set was below a particular threshold, but it doesn't seem like there's an easy way to do that. So I just am like, but it does seem to converge. Okay, and so then, okay, and so then what we're doing is so like these are the four functions selected, and let's see so we were training on 1, 3, and 6, and they were supposed to be -1, 1, and -1. So like 1 is here, and it's all zeros. Like I'm mapping -1 to 0 for the purposes of display. So these all are zeros, and then I think this is 3, and that's all ones, and then 6 I think is like this one. So yeah, so like all the functions it discovered have complete agreement with the training set. So if we then like sort, this is like all functions, or like all functions from this chart. If we sort, we can see that, so like over the 200 trials, when we ran back propagation, it selected these four functions, and so like these are the four functions, and we can see that in this case, indeed, like the two most frequent functions in the weight space were like inferred by backpropagation when training to convergence on the training set. But then you have like weird anomalies that, like, the third most popular function for backpropagation was actually only like the sixth most popular function in the weight space generally. And so I don't know why that is. It's like an anomalous result. We'll just look at two more runs. This is the same inputs with, like, I changed one of the output labels just to mix things up. And so again, we trained 300 neural nets from an initial, like random initialization, train to convergence, then we visualize. Okay, so in this case, it only discovered 2, which, by the way, the training set is size 3. There's 8 possible inputs, so that means there's 5 inputs that are unknown. So therefore, like, there's 2 power 5 functions, 32, that like agree with this training set, or like are compatible with the training set. So out of those 32, backprop and a neural net, only selected these 2 functions. But again, if we look at them in the weight space frequency, they are in this case, they're the 2 most frequent functions. So let's just look at one more training set. So on this training set, I reduced the number of inputs to 2. So there's 2 power 6, which is 64. So there's 64 possible functions that agree with this training set. And so again, out of 300 trials, which I guess isn't that much, but I'm kind of doing this like inefficiently. Like, I don't think you're supposed to like redeclare like every, I should just like reinitialize the weights. But I don't know. I didn't do it that way. So anyway, we have 300 trials, and so it found 4 functions. Like, it preferred these 4 functions out of 64 possible functions that are compatible with the training set. And if we sort by weight space frequency, it's kind of the similar pattern as before, right? So it's like, I mean, clearly, backprop on a neural net, it is kind of picking like the most frequent functions in the weight space, but like there's weird anomalies. Like in this case, the most frequently preferred function was actually, again, only 6th most frequent in the weight space out of all the functions that agree with the training set. I think that's what this is. It's like agreement with the training set. I don't know. Or just all functions. I don't know. So anyway, yeah, those are some results.